Right. There's a lot of information here, and let's just get rid of some of it for now. Let's just ignore these things. We've got a voltage coming from something a bit like a battery, and a voltage over here, and the power, which is the power that's transferred to these homes. So one thing we can do is we can use conservation of voltage to work out the voltage across each of these power lines. There's 3,230 volts difference, and if I divide that by 2, that will give me the voltage drop across each power line, which is 1,615 volts one way and then 1,615 the other way. I can also, from these two, calculate the current that's running through the lines. So that will be current equals power over voltage. 630,000 divided by 42,000 is equal to 15 amps. So I've got 15 amps running through power lines and coming back the other way. Now, from those two, I can work out the resistance of my lines. R equals V over I, 1,615 divided by 15, which is 107.7 ohms. And now I'm using the remaining information and the resistivity equation. So the resistivity equation is that R equals rho L over A. And I can rearrange to get the cross-sectional area. I'm just going to do it at the top here. So the cross-sectional area will be rho times L divided by 107.7. So it's 1.7 times 10 to the minus 8 times 19,000 divided by 107.7. And then that gives me, for the area, 3 times 10 to the minus 6, which I'm just going to put down here. 3 times 10 to the minus 6, which is 3 times 10 to the minus 6 meters squared, which is 3 millimeters squared.